Factoring perfect square trinomials. Now there are two formulas, however, if you forget one of them, you can always factor these by grouping. So if you can rewrite your trinomial in terms of having a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared, then you can apply the formulas and jump a couple of steps. So we are going to factor the first trinomial by grouping. Leading coefficient is 1. 1 times 25 is positive 25. We need two factors of 25 that add up to 10, and 5 times 5 equals to 25. 5 plus 5 gives us 10 back, so we have plus 5x plus 5x. We have two of them, and we keep everything the same. Now we're going to factor by grouping, so we can take out x from here. We can take out positive 5 from here. So this thing becomes x plus 5 plus 5 x plus 5. Let's factor out the parentheses. We get x plus 5 in this denominator, x plus 5 in this denominator. Whatever goes in denominators goes on the outside. This and this will cancel, so we get x plus 5 times x plus 5. This is almost our solution because something times itself is that base to the second power, and this is my solution. Now, using a formula, you can go from here to here in about 3 steps. So let's factor this one using formula, and we have to choose which one to use. And since the middle term is positive, I'm going to use a squared plus 2ab plus b squared equals to a plus b to the second power. So the first thing, we need to make sure that we can rewrite the last term as something to the second power, and we can say 9 is 3 times 3, which is 3 to the second power. Then we want to make sure we can factor out 2 from the middle term, and it's even, so we can say this is 2 times 3 x to the second. Now we can use the formula because this is b, that's a. A is equal to x, b is equal to 3. So this whole expression factors into x plus 3 to the second power, and this is my solution. Let's factor this one. First thing to check is if we can rewrite last term as something to the second power, and we can say 16 is 4 times 4, which is 4 to the second. Then we want to make sure we can factor out 2. 2 times 4 will give us 8 times x to the second. Now this looks like a squared plus 2ab plus b squared, and that thing factors into a plus b to the second power. Now in this problem we have a is equal to x, b is equal to 4, so this thing factors into x plus 4 to the second power, and this is our solution. Here we have y squared minus 12y plus 36. First thing, I want to make sure that this can be rewritten as a perfect square, which is 6 to the second power, gives us 36. Then we want to make sure we can factor out 2 from 12, and we can say 2 times 6 gives us 12 back. And we still have that y, and y to the second. This time we're going to use a to the second minus 2ab plus b to the second equals to a minus b to the second power, because middle term was negative. Here a is y, b is 6, so this thing factors into y minus 6 to the second power, and this is my solution. Here we have y minus 10y plus 25. I'm going to rewrite 25 as 5 to the second power. Check if you can factor out 2, and we have 2 times 5, y to the second. The biggest thing you want to make sure is that these two numbers are the same. If they are, you can just go straight to the formula. Now the first number is y, second number is 5. Because there is a minus in front of 2, it will be a difference, and it is raised to the second power. And this is our solution. Let's factor this one. First thing, let's rewrite 49 as something to the second power, and we can say this is 7 to the second power, plus, make sure you can factor out 2 from 13, and we have 2 times 7 gives us 14 back, x to the second power. Now that these two numbers match, 7 is the same as 7, you can just go straight into parentheses. So this will be to the second power. Because you have plus in front of 2, it will be sum. First number is x, second number is 7, and x plus 7 is our solution. That's all.